Yeah, let's get started. So, I'm Kyle Milani. I am Director of Product Management. And just to help you guys, you just saw the presentation from Joe Pasqua. I'm responsible for the management and security aspects of the product in MarkLogic 9. And for those who attended my session yesterday, I'm also responsible for scalability, high availability of the product. Today, I'll be talking about the roadmap in MarkLogic 9. I'll be covering encryption, redaction, and element level security.
I'm Balwinder Dang. I'm Senior Principal Consultant with MarkLogic here in the UK. I've worked with customers in using the product, implementing the product, and which helps them to leverage their data easily using MarkLogic. Prior to joining MarkLogic, I was a customer working for 6 years with different customers implementing MarkLogic, and fell in love with the product and decided to join MarkLogic. So let's quickly walk through the agenda.
Sorry.
No, it's not a scanner. Okay. Can I leave it open?
Yeah, leave it open.
Okay. So I'll leave it open. So we're going to talk about the typical enterprise deployment architecture as it is used in the enterprises today. How enterprises currently deploy their systems and secure them. Then how MarkLogic Security can enhance such a deployment and work in it. And how you can deploy MarkLogic securely and what's upcoming in MarkLogic 9. You would have heard Joe Pasqua talking about the security features, and I think Kayo is going to go in detail on that. So what does this picture tell us? So it's a chain linked with a thread and doesn't look very secure. And if you're looking at this picture, you can say that whatever it is trying to secure, it's not good. But what if this view is abstracted from you, or you are not able to see this view? You would think that everything is secure, however it is not. So security is as strong as the weakest link in your enterprise. And you need to secure the entire enterprise deployment to make your system secure. This is the current typical enterprise architecture which organizations use. It's a 3-tier. You have the public network, the DMZ, and data tier. Now, this could be on-premise or off-premise in the cloud. Those decisions are made usually based on cost or data classification. So if your data is high value or you are under regulatory compliance to follow certain standards, you might decide not to deploy it on cloud. However, even on cloud these days, Amazon and various cloud providers are coming up with features that allows you to deploy even sensitive and high value data in the cloud. So irrespective whether it is on-premise or off-premise, the typical architecture has been like this for years, and although you might had multiple layers of firewall here between your DMZ and your application services, but logically it looks like this. So you have your public network, your end user applications, third-party services. You have your demilitarized zones, DMZ, where you have identity management and your application services. And you have your data tier, which is where your data resides. All your database management systems are running in this data tier. And you'll have firewalls between them. Now, it is necessary to secure the entire stack. So we cannot just secure one of the tiers and think that it is secure. As I said, security is as secure as the weakest link in your enterprise. So it is necessary to secure all the 3 tiers here, the entire stack in your system. And then you can be sure that the whole system is secure. So let's look at the 3 pillars of security: confidentiality, integrity, and availability. Confidentiality is right person having access to your data. Integrity is ensuring that the data is not modified in transit, and throughout the life cycle of the data is not compromised. And availability is making sure that data is available to the authorized user. So for example, denial of service attacks, where a potential attacker would try to load your system so that it becomes unavailable to the authorized user. An example of confidentiality would be people using encryption to ensure that the data is confidential and it is delivered confidentially to the right user. Integrity is, example of integrity would be using checksums to ensure that what is delivered in the transit is not modified and is the same during the delivery and during the life cycle of the data. So let's look at the 3 A's of application security. So we have authentication, authorization, and auditing. Authentication is validating the identity of the principal. Now, principal can be a user, an application, service, or a machine. And once a principal is authenticated, it becomes a security principal. Authorization is ensuring that the authenticated security principal has the right access to the right resource. And these two are different. So sometimes people think they're the same, but they're not. For example, you might have username, password, credentials, and you might log in, but you might not be authorized to do in the system. So even though you're authenticated, you don't have access on any resource. And auditing is ensuring that you can monitor and capture that your security policy is working properly and that the right people are getting access to the right resource in the right manner. So authentication and authorization are happening properly and there's no misuse happening in the system. Now in MarkLogic, security is core to the product. It's been there since the very first release in the product. MarkLogic is a leader in the industry. We have a lot of certifications under our belt, and we have a strong track record of delivering incremental improvements to the product. Sometimes some vendors they start building the features and functionality in the product, and they think about security, then they realize at the end that they want to give granular access to the product and to the application, and that's at the later part they start thinking about security. Now that is what we call bolt-on security. It's not very integrated. It's cannot be delivered properly across the application. In MarkLogic, we do secure design, we do threat modeling and vulnerability analysis at the design phase of every release, and we plug the gaps and the weak links that we find in the system at the beginning. And hence, we are common criteria certified. We are the only NoSQL vendor to have this certification. It is a very renowned certification. We are very proud of it. We are also certified to run in classified government system. We are ICD 503 and DITSCAP certified. We have MarkLogic is running in a lot of federal agencies in the US, and also in UK here we have a lot of government customers already running MarkLogic. Now, how does MarkLogic deliver authentication? So in MarkLogic there are 2 ways. You have local authentication where users are maintained locally within the MarkLogic security database, or you can have distributed or delegated authentication. For example, you can use a namespace directory like LDAP or Active Directory and integrate with it. MarkLogic can integrate with it easily using some configuration over LDAP, and you can authenticate your users against a centralized Active Directory or a lightweight directory. Now, we also support Kerberos authentication, which is a ticketing-based authentication, which is mainly used in Microsoft environments, which allows you to authenticate a user using a ticket-based system, using a Kerberos distribution center. So how does MarkLogic deliver authorization? Now, MarkLogic has various access control models which it uses to deliver authorization. And you can use roles or compartment-based security. You can use access attribute-based access control, label-based access control. And so one question that comes to mind is, why is authorization important? So authorization is important could be because of regulatory reasons. So you might have regulatory reasons to say that you should report on who accessed what, when, and what was modified. So it's important to have a good authorization model. And when you are designing your system and your security model, you should try to segregate and have separation of concerns. For example, your database administrator should not have access to the operating system, and your operating system should not have access to database. Now that's the most secure model, but sometimes these things overlap. Your DB might have access to your system, and if you're running in such a model, then make sure that you have auditing turned on, so at least you know who did what, when, and why. So going a bit further into the authorization model, so role-based access control, and the other models I was talking about, attribute access control. So role-based access control is a user will have one or many roles. Each role can have one or many privileges and permissions. Now privileges are two types in MarkLogic: URI privileges and execute privileges. URI privileges allows you, gives the privilege to insert documents under a certain URI prefix. Execute privileges give access to certain functions. So it allows you to execute certain functions. An example of an execute privilege would be, you have a database administrator who wants to take a backup. So you would have a role which will be a DB admin role and will have the privilege to execute the backup function. Whereas a developer will have a different role and would not have that execute privilege and is not allowed to take backups. Permissions is the granular level where you put on the document what roles can read, insert, or update that particular document. And a mix of these two, privileges and permissions, will give you all the access control that you need for that role. Now, attribute-based access control, policy-based access control, label-based, these are going further down into the granular level. Attribute-based access control is like cell-level security. So if you want certain elements in your document to be secure, or only certain roles having access to it, then you would use attribute-based access control. For example, NI number, personal identifier information, any sort of tax information which you want, which is at the cell level and the element level, then you would use the attribute-based access control. Now MarkLogic, in addition to this, on the role-based access control, provides an additional feature called as Compartment Security, which is a very good feature, which allows you to manage entitlement. So what is entitlement? So authentication is user logging in using username, password. Authorization is based on the roles, they can access do certain actions or access certain documents. So let's take an example and delve a bit into compartment security. So we have two users who are working on an application. They belong to two different organizations and they're both employees. They have two documents which they have created, and so employee role has read and write permission, and ABC Corporation is a role having read permission. And similarly, these are two roles from the other organization. Now, in a simple role-based access control, what this means is this user here, who's an employee, can actually access this document. Because to access this document, you just need one of these two roles. Now, this is where the compartment security comes into picture. And logically, you would not want it, because if you want to implement entitlement, you want only the user of this organization to be able to see this document, user of this organization able to see this document, not vice versa. So compartment security allows you to compartment the roles, put a label on the roles and say, okay, these two roles are compartmented and they have a compartmented called organization. So they belong to the same compartment, which is organization. What this means now, user of this organization who is an employee cannot read this document because a compartmented role, which is this, is ANDed with a non-compartmented role. And so you can build a very robust entitlement model. So traditionally what people do is they build entitlement model in their application layer, which is not very secure. I mean, if you can bypass the application layer, people can look at the data. It's not at the data level. Whereas this allows you to go further fine-grained, implement your entitlement at the document level, and it's in the document. It's in the permissions of the documents. So how does MarkLogic deliver auditing? So MarkLogic has a very robust auditing capability. You can enable it at the cluster level. It will audit who accessed what document, what updates were made, what configuration changes were made. You can audit on administrative actions, code execution, even changes to access control. So it gives a varied set of functions and varied set of operations that you can do in MarkLogic. You can audit them, and it will produce audit logs, which you can then capture it in the audit logs and you can keep them based on your regulatory or compliance requirements for how long you have to keep them. We also have a secure versioning support, so you can we have versioning APIs which allow you to version all the documents, which are sometimes required for, again, compliance reasons in organizations. And a lot of our government customers are actually currently using this versioning functionality. So how do we make this system secure? So this is the same enterprise deployment architecture. We are deploying MarkLogic on it. And we have the end user clients here, we have the app servers and the data tier. And how can we make this secure? So the first step is to harden the environment. So we start with hardening the end user tier. So so by default, we should not trust anyone. All devices should be untrusted, all users should be untrusted. So what it means is everybody who is trying to play in your ecosystem needs to authenticate. They need to have a valid username, password, credential, or any other form of authentication, for example, multi-factor authentication. First, they have to authenticate themselves. So you should, and then you should provision credentials using well-trusted certifying authority. So you should not use self-signed certificates. You should try to get your certificates from well-known certifying authority, because there is a lot of process that goes in issuing a certificate. So it's good to have it. You should enforce the password policy for the end users and devices, and you should consider using multi-factor authentication. Now, multi-factor authentication is something we use on day-to-day without realizing. For example, an ATM card. It's a card that you have, and it's the PIN that you know. So it's two factors. Without having both, you cannot really withdraw money from the ATM. So it's a two-factor authentication which we use in day-to-day. Similarly, online banking. So you have key fobs these days to access your account online. That's again multi-factor authentication. And this is all dependent on the data classification. So if you have high-value data, right? If you have data which is sensitive and confidential, then you should look at using multi-factor authentication. And key fobs, even some customers are even using biometric to authenticate users, to ensure that a certain sensitive data is only accessed to the right people. Then we go to the app services layer, and you should harden this layer. You should ensure that your operating system is up to date. You have security patches updated. You remove unused services. By default, there are a lot of services which are enabled within the system, and default ports are open. So you should have a checklist against which you can check and ensure that you close those default ports and default services. Because a potential attacker would be looking at those things and trying to penetrate your system using those default ports. Consider using machine-to-machine authentication. Kerberos is a very good example. It allows you to do machine-to-machine authentication. Ensure your load balancers are configured correctly. So we have seen some customers where some problems where the load balancers were not properly configured, and that caused them some problems. So it's important that you configure them correctly. Always use mutual authentication between endpoints, and use enhanced IDM services. So don't use the default port 389 for LDAP. Use 636, which allows you to secure and start a TLS connection from the client. And finally, we come to the data tier. Now, to harden the data tier, we do whatever we talked about before, which is the security patches, operating system, multi-factor authentication. Plus, we do more, because this is the tier where your data resides. So if you're worried about your data, the value of your data is pretty high, and you're worried about it being stolen or lost, please use data encryption. You can do that currently with MarkLogic 8 using third-party services like Warmetric, SafeNet, and a bunch of others. Tools used for transparent data encryption. And these are services which sit between your application and your disks, and they encrypt the data in and out. We have done some testing against them and certifications, and you can use them currently with MarkLogic 8. And again, it is dependent on the data classification. So the type of data you're storing is important. So if, for example, you have currently organizations do data classifications differently. So for example, HR data and finance data is considered to be more secure and needs to be secured properly. Whereas you might have some public information or public data which needs to, which is on your public website, and you might classify that as medium value data, and it can be in less secure environment. However, there should be nothing in your enterprise which is low value. Everything should be either medium or high value.
Excuse me, so can I ask you something? So,
Yeah.
Sorry, saying that address in the physical storage should be or could be encrypted.
Yes.
So if you do that, wouldn't it affect the indexing process and all that?
No, so I think we did some testing on it, and it's the performance was in like single digits with disk encryption technologies like Warmetric and bunch of others, and we the performance hit is like 6%. It's in single digits, very low. So if you have high value data, it's advisable to encrypt it, and it should not have.
Yeah, it's transparent to the database. I'll talk a little bit more about how we are doing encryption, and I can address as well how you would be doing with a third-party tool.
Yeah. So secure the application deployment. This is just a recap. You secure your end user client authentication. Secure the pipes, all the communication from the end user to the application services. Use SSL. Secure the connection between the app servers and the end users. Secure the connection between the app servers and the database tier. And once you have done all this, you can be assured that your entire stack is secure, and it's sort of you're making it difficult for the potential attackers to try to exploit or get into your ecosystem. This is just a summary. It's combined. It's in 2 tiers now, but I think the principles are the same, whether it's a 3-tier or a 2-tier, and the security model and the processes you follow to ensure that everything is hardened is still remains the same. And I think Kayo is going to talk about what's upcoming in release 9 now, so I'll hand over to Kayo.
Is there really a firewall between inside MarkLogic if you use MarkLogic App Service? Because on the last slide, there was a
Yeah, you can use that. So that is one deployment scenario where you can have it. The other deployment scenario is where you will have your E nodes and D nodes all within the data tier. And then you might have an application tier like a Java tier or a web app tier like Node.js, and then you'll have a firewall between that. So this is one type of deployment, and typically it's a 3-tier where you'll have some kind of an app tier in the middle with Tomcat, .NET, like middle tier. Yeah.
separate ED nodes.
Yeah. If you separate E and D nodes, you can deploy it like this. Yes. Yeah.
I see.
Okay, so now I'll be talking a little bit about roadmap. So we learned a little bit about the CIA model, the confidentiality and integrity. So I'll be talking about features that will enhance that. And the first one is the encryption part. You already learned a little bit this morning from Joe. So the goal here is to prevent the sysadmin or anyone who has access to the file system from being able to have access to the data files. So since the files will be encrypted, it will be very hard for anyone to read that data or even move to a separate server. And that will reduce this type of risk. It also helps on tampering information. Since the information will be encrypted, it becomes really, really hard to modify that information without pretty much crashing the server. So you're also enhancing the integrity of data with encryption. And we see many customers in government and financials that have actually mandates that tell you have to have encrypted data. So we'll be helping here. So who should care about this? So we see in the financials, customer data. There are lots of regulations about you have to encrypt customer data. Government, both the intel side, the defense, and the non-defense side, they also have data that is important. They should encrypt. We actually have the entire US government has to encrypt data. It's a mandate. Healthcare, we have mandates about notes from doctors and things like that about a patient that they have to be encrypted. Publishing. I'll give you an example of why publishing should encrypt. So we have here 3 publishers that work in the financial industry, Business Wire, Market Wire, and PR Newswire. These companies, they receive information, market information, a few hours before it should be published. Let's say results from the quarter for the company, and at the end of the day, they publish. But they receive that information a few hours before it's published. The information in these 3 companies was in a database that was not encrypted. What some hackers did, they actually got the information while the market was still open and traded on the information. $100 million in profits. Very easy, just get into the file system and read the data. So now they know that they have to encrypt data. Another example, if you have an online presence, we have another customer that had an encrypted database. The database, you can actually, if you go and search, you can find an entire database from Ashley Madison on the web. They simply downloaded the database. It was a MySQL database. Unencrypted, you can load anywhere. So they had access to all customer data. So pretty much every industry should care about encrypting. So let me tell you how we are doing that in MarkLogic 9. We are doing what is called transparent encryption. We are encrypting 4 things. We are encrypting databases, logs, config files, and backup. Databases, you can choose which database you want to encrypt. And it's called transparent because once the DBA sets that, there's nothing that the developer has to do in the application to use that. It's done at the MarkLogic process, so before it saves to disk or reads from disk, everything is encrypted. Okay? When it transports out, we already have encryption. So data that is coming out, it's encrypted at transport. Yes?
Are the caches encrypted?
Memory? Or everything that is on disk is encrypted. Memory is not.
Disk, it's encrypted.
Yeah, memory is no.
Like a tree cache.
Memory is not encrypted. Everything on disk is encrypted. We support 2 models, a local or external key management system. Local means you are entirely reliant on MarkLogic to generate the keys. And an external, you have an external key management system that will generate the keys. In my next slide, I will explain how that works and how it enhances security. And if you have a separate key management system, you may have separation of control. Here in my example, I have a DBA and a security admin. So who issues the keys is a separate person. So it becomes very, very hard for the DBA to actually move data around without talking to the security admin, because you would need keys to open the database. And as we already talked about, performance here, which is the common question, is this affecting performance? We already did a bunch of tests, and performance very low single digits. And you can actually check that, because this feature is already available and in early access. So you can already try the database encryption. Logs and configs are not there yet, but database, you can already try that. So let me explain a little bit key management. So here I have a typical deployment when you are using an external key management system. So I will start from the bottom, the keys that are in the black boxes. So again, I have encryption for databases, would be the object, config, and logs. So each different type of object, you can have a separate key. So for instance, you may have keys for logs. So you may provide those keys for someone who will only have access to logs, not to data. Same for configs and same for databases. At the database level, the object, what we're doing, we are generating keys for each stand. For those that are familiar with MarkLogic, we save things to disks in stands. So each stand will have its own key, and we keep generating those keys automatically. So a typical database will have hundreds of keys. So that means that each different stand is encrypted with different keys, so attacks such as trying to find out how we save information to disk become very, very hard to be done. So, but you may be concerned, how do I manage all those keys? So by having an external key management system, we do what is called an envelope. We get those 10 keys, we send to the key management system. The key management system will encrypt with a key that MarkLogic will never know. The key is inside the key management system. And we receive back an envelope. We save that to disk. Every time that we need to open and stand, we have to send it back to the key management system. It will open, send back the key to us. So if the key management system is not available, you don't have access to data. And that's exactly what you want, because if data moves out of the data center or moves out of the server, it becomes impossible to open that data. That is the goal. And typically, key management systems are highly available and redundant and high performance. So they can generate thousands and thousands of key operations per second. So this is the most secure way of doing, but it's not the only way. We support both the green and black keys, all provided by MarkLogic. Yes?
Is the key management system part of the MarkLogic?
No, this will be an external. As I said, you could.
Yeah.
If you don't want an external, we will generate all keys for you.
Okay.
But that's not the most secure way.
Yeah.
The most secure way is to use an external key management system. And typical brands are Vormetrics, SafeNet, Tails. Those are the vendors that provide that. Even Amazon has a service called Cloud HSM, which is a SafeNet rebranded, that will provide that capability for you. So that's the most secure way of deploying. So we support both. The other two features that we are introducing are related to granular permissions to information. We already have document level security, so you can already control at the document level who has access to, and we talked about compartment security on the document side. We are taking a step further and going inside the document in two aspects. The first, at the query time. So when you're doing queries, we may allow you to control which information inside the document is concealed. And as well, when you are exporting data, let's say you are exporting data for development. Developers shouldn't see all the information, but they typically need some information. You don't want to provide a credit card number to a developer, but they need a number to do tests. So we also have the redaction feature, which will help you generate random numbers or mask numbers. So let me talk about these two. Let me start with an example for us to understand element level security. So I have here a document that has 4 pieces of information. And I have a classification. So unclassified, secret and top secret. That is the classification that we have there. So what you'll be able to do with element level security is set up a role that has the unclassified role and has permission only to see that piece of information. So when you do any search or any FNDoc operation, that's the only information that someone with the green role here will see. If you have a secret role, you may be able to see the 3 pieces of information. And finally, if you do have the top secret, you will be able to see the whole document and actually search. If that person searches for Mike, there will be a hit. If the other 2 folks search for Mike, no hits, no documents will be found.
This applies only to XML documents or also to, for example, JSON data?
JSON and XML. Let me talk about how it works. So how it works? Well, MarkLogic has no schema, right? And we don't know how data will show up. So we address that by using XPath expressions. So we'll create a rule. For instance, the function is called protected path. And I'm saying that any element that has the classification unclassified requires the role, unclassified role, to read. So it doesn't matter the structure of the document, doesn't matter how the document comes in, how deep the document and the structure is, as long as there is something telling that that information is unclassified, it will require that particular role. And then I have the second role here, the top secret. Okay? So it allows you to continue to have the flexible model, no schemas, and still protected data. And it works with XML or JSON, and the expression will work across. It works on queries, updates, and all search, as I mentioned.
Can you have it so that you have a role which can search across it, but when it's returned, they can't see the data, so it's like for tests? So you as a user could search across a redacted element, and when you get it back, you can't see it?
No. No, pretty much if you can't see, you can search. No, absolutely no leakage of information. That's the goal.
For the previous document that you just showed on the screen, if you don't have the top secret permission, would you still be able to write to the document?
We have a new type of operation, which is an update to an element. So you will be able to write to elements that are not protected. So for instance, if you want to add an additional piece of information here, you'll be able to. We have a new type of permission.
Supposing you posted effectively a new version of the document.
You would need to have an update on the entire document. What we're adding is called a node update. If you only have node update, you will, for instance, and you are going back here or the blue, you cannot update the red node typically. But you could add information, you could update the other 2, but you cannot update the top secret element.
Right.
If you have a document update, you can overwrite everything. But that goes back to our versioning. So you should version the documents or use bitemporal. Okay, so again, it works across, same rules will work across XML and JSON. You just write one protected path and you're good to go. Redaction is the other side. It's for when you are exporting data.
Just one question to that. Do you means you have to have the security attributes on every element? Or
Well, the security, he is asking if you have to have, the way I created my rule here, I'm using the security attribute, but it's XPath. And I'll actually show an example in the next that I'm not using an attribute, I'm just using the element name. So XPath will support anything, even an element name. My next example will address that. So here I have redaction, so I have a piece of information about a patient, and forgive me here, I'm using social security numbers, US example, but the same applies to UK numbers, which I actually don't know what is the...
And I know.
Yeah, thank you. So for a developer, I just want to export data for that database using MLCP, but I need some information there, but not the real information. So I'm applying 3 types of rules here. The first one, I just generated a random string. The second one, a random phone number, and the last one I masked. So I'm masking. I still have the last 4 digits, but I masked the other. So 3 rules here. Same thing, how we manage that in a schema-less database. We're using the same concept here, expat. My example here, different. I'm just using SSN. So that's it. I'm using the element name to redact. And this is more a policy-based, so you create the collection of policies. Let's say for developers, you want to mask data. For sending data across the channel, you need to remove data because of regulation. You have different policies, and every time that you are exporting, you apply a different policy. So my example here, I'm applying my redaction collection of policies, which are pretty much documents. Out of the box, you can conceal information, pretty much hiding completely the information. Just a second. Or you can create random strings, as I exemplified, or what I call deterministic. I always want the same string to be generated from the same source. This is not very secure, but it's required in some scenarios. And we have patterns. You can find a social security number, US phone, email, IP address, and redact those as well. Yes?
Is this part of the role as a separate attribute or a separate field, or is it a privilege that can be just used within the role?
To export?
Well, to enable redaction.
Well, with redaction, you will create the rules and put them in documents. And then you execute the MLCP. First you need a privilege to execute MLCP. And then you also need to have access to the data before you redact that data, and access to the policies. So everything is controlled in different privileges and permissions to ensure that you can properly redact.
What would happen with the masking if your social security number in your document is invalid? So if there's invalid information inside your documents already.
Right. So if you are using our pattern masking, it will not find that information. But my example here, I'm not using the...
Will it be unmasked then in the return, or will it just...
Well, if you're using the pattern, it will try to find exactly a social security number. My example here, I'm not using that. I'm just using the element. That is irrelevant of what is inside. If you want to use element names, fine. Doesn't matter what is inside. This is to actually find information inside the notes. Let's say the doctor notes, somehow somebody typed a number there. That will actually find inside a long piece of text and redact that. That is a little bit deeper. This is just redacting the entire thing, concealing or masking. So, wrapping up here, we talked about that security is as strong as the weakest link. So we learned that it's not only about MarkLogic. If you only protect MarkLogic, not enough. You have to protect endpoints, application servers, and MarkLogic. We talked about the different ways to authenticate. We have local, so you can actually create users locally. Or you can rely on LDAP or Kerberos. We talked about the multiple ways of controlling who can do things. We talked about the privileges. And we talk about permissions, who has access to documents. So that's 8. In 9, we talk about, okay, you can even go inside documents and tell who has access to elements or JSON properties. We talked about auditing. Turn on auditing. You will know who is doing what all the time. For instance, when you are using now redaction, you will know who exported and what rules were applied. So you can keep track of what information was given to a developer, for instance. You will have track records of everything that is happening. And as I mentioned, we are improving security across many features here in MarkLogic 9, help you deploy in the cloud more securely, help you comply to regulation, and help you accelerate how you provide data to developers or partners. I already answered questions, but let's open to questions for me or Alvinder. Yes?
Is it possible to assign permission and roles to classes of documents, for example, documents belonging to a particular collection, or sharing a common subtree in the URI, a prefix of the URI?
We have security is at the document level. So each document, you will tell who has access. What we also have is called a protected collection. But what it prevents is you from inserting documents into that collection. It's kind of preventing the bad guy from putting information into a particular collection. And if you're using that collection as a secure group of information, you can prevent unauthorized users from adding documents to that collection. But there is no way of, okay, I want to tell who has read or write access to the entire collection. This is per document. And with 9, we're kind of getting per element, kind of per cell, if you would compare it to.
So you can have
Tabler.
default permissions at the role level. So if you are a user and you have, say, 5 roles, at each role level you can say these are the default permissions. So if you insert a document, all the default roles defined for your all the default permissions defined in your roles will be attached to that document.
But it's not possible, for example, you imagine you have a folder represented as a URI bar. To say, okay, all contents within this folder or this subtree is protected by, let's say, view or read or write permission. That's not possible?
So that's the protected collection.
Okay.
Only for inserts, and if you have default roles, you're getting whatever is part of the default role. Yes?
So on compartmental protection, is that kind of static per document, or can we do it on something like this has an element which has a date of less than 3 months from now, something like that?
So you're talking about compartment
Compartment
security?
security based on information inside the document.
Yeah. Is that possible, or is that still application level?
It's at the application level, you would have to find the information and then set the role that is required. Yeah. Yeah, at application for now, application in 9, you can play with element level security to add to compartment security as well. Okay, thank you.